Hi everyone, Miss Andronicus here, and today we are looking at maps and bearings. So, another kind of compass is used historically by travelers to find directions. So as you can see here, there's that north, south, east, west, and then northeast, southeast, southwest, northwest, all the way around. It's of course inaccurate for modern day travel though, and these days we now use bearings. A bearing is an angle measured clockwise from north. So bearings are usually stated as three figures. A bearing of 35 degrees would actually be written as 035 degrees. So let's have a look here. We've still got the directions, north, south, east, west, etc. Except we now also have these degrees. You can see how they go clockwise, like our clock, around from north. North is 0 or 360, okay? And then we just head around in that direction. It is always clockwise from north. Doesn't matter how or what you're doing, you've always got to go clockwise from north every single time. That's very, very important. A protractor can be used to measure bearings, and here let's do one example together. So you should have your protractors handy. You've got points A, B, C on a map. Measure these three bearings. I want you to give that a go and pause the video now. So you should be putting your protractor, and I will film another video to be able to assist you with this, where you put your protractor on 0 in the middle to be able to measure bearing from A to B. So we're going from A, which means A needs to be allocated north, okay? So that vertical line of north starts from A, because that's where we're going from, and we want to measure that angle to B. So we've got to go from north clockwise, measuring that angle to B, and you should have gotten 130 degrees, roughly. Measure the bearing from C to A. So now we reset this. We've got to decide where we're going from. Wherever we go from has north attached to it. So we're going from C this time, and we're going to A. So we've got to draw that line to A. And again, measure the bearing clockwise from north. This time, it's 65 degrees, and I hope you wrote that as a three-figure bearing. Now, C is a little bit tricky. Of C from B, okay? So if we're going from B, okay, from B, B needs to have north. And we need to then go to C. And remember, we've always got to go clockwise. So we've got to go all the way around that side to get to C. So we do need to measure that reflex angle, or we could measure what this one is and subtract it from 360 to get the angle going all the way around. Either way, you need to come up with the angle of 277, roughly. So another way bearings are found is by mathematical calculations and angles, and this is probably a bit more common. So the bearing of N from K is 48 degrees. Find the bearing of K from N. So first we need to mark our diagram up so that we can visualize what this question is saying to us. So we're going from K, so that means K has the north for now, and it's going to N, and that is 48 degrees, this angle in here. Find the bearing of K from N. So now it's asking, okay, if N has north, what is it going back the other way? Now, this is not to scale, so we need to figure out a way to calculate that. So here is where we need to actually utilize our angle knowledge and our angle knowledge of parallel lines. So we can see straight away by putting lines and arrows on these, okay, they're nice straight lines, that means both of those north, they're both pointing north, therefore they're both got to be parallel, okay? North is always straight up, at 360 degrees or 0 degrees. So in this case, they are parallel lines, which means all of a sudden we've got an angle that looks very much like co-interior angles. So this is 48 degrees, which means whatever this angle is has to add up to 180 degrees. So if I do 180, subtract 48 degrees, that leaves this angle to be 132 degrees. Now that I have this angle in here, I can work out the rest of it because it's 360 subtract 132, which is going to leave me with a bearing of 228 degrees. There's our answer. So you need to be really aware of your angle rules, specifically your co-interior angle and angles around a point, as well as asking yourself in the end, of course, how reasonable is my answer? 228 degrees. Okay, another aspect are map scales. So on maps, of course, you can get bearings and things like that, but also you've got to be aware of the scale of maps, okay? They provide map scales to accompany any diagram that is drawn to scale. They're sometimes given as a ratio, and in that it is always in centimeters. Although the unit is never written, that's the rule of ratios, is that it never has a unit. So you need to follow those rules of ratios with map scales. And with that ratio, the distance or the measurement on the map is always that first number in the ratio, and then the equivalent measurement in real life is always that second number for the ratio. So let's have a look at an example. A scale of 1 to 100,000 means that that first number is 1 centimeter, and that's on the map. And the second number is again in centimeters, and that's in real life. So that 1 centimeter on the map is 100,000 centimeters in real life. So you could write it as 1 centimeter to 100,000 centimeters. Be aware though that this is the official ratio form, this is not, but you can write it out to help you. And then using the conversion of length, you could also say, once you've converted it to meters and then to kilometers, you end up with that as the ratio. So 1 centimeter is 1 kilometer, and that makes actually the conversion very, very easy in this example. Here's another one. The scale of a map is 1 to 420,000. A road on the map is 4 centimeters long. How long is the actual road? So you need to be aware that you have map and then you have real life. Okay, that's your ratio. You got the map on the left and then the real life length on the right. So that in this case, it's 1 to 420,000. So write it as such. Then the rest of the question, we're working with a distance that's on the map. So I'm going to put that 4 there on the map side. How long is the actual road? So this is the blank that we need to figure out. So you just need to simply do the conversion. So how does 1 get multiplied up to become 4? Well, it's multiplied by 4. So this side, you do the same thing and multiply it by 4. So that ends up equaling 1,680,000. Okay, now how long is the actual road? So yes, technically 1,680,000 centimeters is a distance. However, if someone said to you, how far away from the park do you live, you're not going to speak in millions of centimeters. It's just not reasonable. So really, you should be taking that centimeters, that's in centimeters, and converting it to something far more realistic that you would say. So again, if I, think of my tricks to be able to convert, I know that that's meters. I convert then to kilometers. I know that this is 16.8 kilometers, and that is a far more reasonable way of putting and submitting your answer. Okay, so one final thought. Sometimes questions will also give you a diagram to measure distances accurately with a ruler, for example, before converting using the given scale. Questions with diagrams of course, may also link to bearing. So you might not only have to know what bearing one town, let's say, for example, is from another, but also then you measure the distance between them. So this is how they relate. Give it a go. Good luck.